So now we will have a video for CMOS layout designing practical number 1, where inverter video is already prepared. Now we will go for the NAND circuit diagram. So for NAND we will need 2 NMOS in series and 2 PMOS in parallel. So I will go to a palette. If this palette option is off, you can open it from this. Turn on the palette, select NMOS. So here you can change the width and length of NMOS transistor, and NMOS के लिए input कितने चाहिए, that also you can change. For our case only one input is sufficient. If you have more than one inputs, you can select this type of transistor also, multi-input transistor, but for our case one is sufficient. So no need to change anything here, just select NMOS and click on generate design. We'll get the NMOS terminal here, NMOS transistor here. Again we want second NMOS, so select again NMOS, go to generate design, and as we want it in series manner, we will try to place it. Just a minute, again we will delete this, unwanted things are added. So go to gun section, delete individually. It will delete everything. Whatever we click, it will try to delete those. So for this practical, try to use mouse, like a manual mouse instead of laptop mouse. That will make you draw the diagram easily. Select NMOS, select again generate design and click. So if I double click, it will show like this. So I don't want to double click. Just do a single click and place it here. Now as I want to make them in series, I have to ensure that drain terminal of one transistor should be connected to source terminal of other transistor. So I have to make this arrangement in such a way that this will come in line with this. Otherwise we can rotate this transistor, because this is bilateral, it is having same terminal. So we can have drain here, source here, or we can also consider this is my source, this is my drain, because both the sides are equivalent. So either I can shift entire thing or I can shift this. Both are okay, both can help us. So for simplicity I will try to shift it. So I have selected the transistor using an option of this stretch and move. This is the option of stretch and move. So if I select this option, I can move the component. Stretch and move, then click here and then draw box and then move. So I am moving in such a way that this blue come in line, and I will try to short them. So either I can take metal one and I can draw like this box, select here pencil, after pencil select metal one, and then you can draw like this. Otherwise there is one option, go to stretch, and you can stretch the width so that the other width will remain common. Like this also you can short it here. And undo is allowed only once, so I will do Ctrl U to undo to get the previous design. So this is my NMOS 1, this is NMOS 2, they are in series. Now I want 2 PMOS in parallel, so I will select this, go to PMOS, generate device, and place one PMOS here. Again I want one more PMOS to be in parallel, select here, and second PMOS. So 2 PMOSes are drawn. Now here also there is one possibility. What we can do, we can create one single N-well. ये N-well दिख रहा है ग्रीन कलर का with green dots. इसको एक सिंगल भी बना सकते हैं या अलग अलग भी रख सकते हैं. अभी फर्स्ट टाइम वर्क कर रहे हो, सिंप्लिसिटी के लिए यू कैन कीप इट सेपरेट so that you can identify this is first PMOS, this is second PMOS. Otherwise for जैसे जैसे आपको एक्सपीरियंस आएगा आप क्या कर सकते हो, एक ही एनवेल में 2 PMOSes साइड बाय साइड रख दिए तो भी वो पैरेलल हो जाता है. नाउ इन अवर डायग्राम व्हाट वी वांट दिस टू इन सीरीज, दिस टू इन पैरेलल. सो पैरेलल पर्पस व्हाट वी हैव टू डू, इन दोनों के जो सोर्स टर्मिनल है उन दोनों को शॉर्ट करना पड़ेगा, इन दोनों के जो ड्रेन टर्मिनल है उनको भी शॉर्ट करना पड़ेगा. सो फॉर दैट रीज़न आई विल अगेन टेक अ पेंसिल metal one. I will try to draw this. I think mouse, we need a good. As I want to connect this blue with this blue, so I will try to stretch this first and then I will directly short it so that it will be in parallel like this. Now I will try to short it. So दोनों के ड्रेन किए. यहाँ पे अनवांटेड पार्ट है, that also I can delete by using gun, and select to delete you can do. Like this. Again I want this to be stretched out. इसको स्ट्रेच करेंगे फिर शॉर्ट कर देंगे. तो दोनों के सोर्स को मैं एक्सटेंड कर रहा हूँ ऊपर और फिर इसको शॉर्ट कर देंगे सो दैट दे विल बी इन पैरेलल. तो दोनों के ड्रेन शॉर्ट किए, दोनों के ड्रेन नीचे वाले शॉर्ट किए, दोनों के सोर्स शॉर्ट किए, तो ये दोनों पैरेलल हो गए, ये दोनों सीरीज़ हो गए. तो आउटपुट में हम कैसे करते हैं, इनपुट एनमॉस और पीमॉस को कनेक्ट करने के लिए विल ट्राई टू हैव दोनों एनमॉस जो सीरीज़ में किए हैं विल सिलेक्ट दो, उनको थोड़ा सा नीचे लेके आ दो सो दैट यू कैन प्रॉपरली ड्रॉ इट. इसको मिडल में ले लेते हैं. I will try to stretch this. So what I have done, NMOS, last NMOS, इसका source drain, उसका source drain, and then drain is shorted with the drain terminals of 2 PMOSes. So यहाँ पे मेरा junction है जहाँ से I can take an output. So again I will try to draw one metal. I will try to stretch it out. थोड़ा सा विड्थ छोटा दिख रहा है, ये इतना लिया तो वो एरर देगा, थोड़ा सा बड़ा करना पड़ेगा. Next I have connected the output metal. I have taken it outside to connect the output. So this is the output I, which I have to select as a visible node, place it here and give some name as out, but don't use keyword. For output I am just using a name OP. Assigned, so output is assigned. Now we have to connect VDD and VSS. So ये VDD हमारा VDD NVL को देना पड़ता है, दोनों NVL को देना पड़ेगा, तब जाके PMOS के पोलैरिटी आ जाएंगी. सेकेंड, इनका जो कॉमन टर्मिनल रहता है सोर्स, उसको जो ऊपर VDD लगाना पड़ता है, दैट आई विल प्लेस इट हियर. सो ये VDD का काम हो गया. नेक्स्ट ग्राउंड टर्मिनल, ये थर्ड वाला ग्राउंड का ऑप्शन है. दिस शुड बी कनेक्टेड टू लास्ट पार्ट ऑफ द ट्रांजिस्टर. तो दो एनमॉस जो बना है एक के बाद एक सीरीज, उसमें लास्ट वाले जो है वहाँ पे उसको मैंने ग्राउंड कर दिया. नाउ इनपुट इज रिमेनिंग ओनली, रेस्ट ऑल इज डन. वी हैव कनेक्टेड VDD टू NVL एज वेल एज टू सोर्स टर्मिनल ऑफ बोथ दी PMOSes. दोनों एनमॉस सीरीज़ में लगा लिया, अभी सिर्फ इनपुट देना बाकी है. तो इनपुट ये क्लॉक पल्स ले लो एंड प्लेस इट ऑन दिस पॉलीसिलिकॉन. सो इसको मैं लगा रहा हूँ, इस पर क्लिक किया, ये मेरा क्लॉक 1 है, इसको एज इट इज़ असाइन किया. आई हैव क्लिक्ड हियर अगेन एंड देन आई हैव प्लेस्ड क्लॉक 2. ठीक है, तो ये क्लॉक 2 जो इसका फ्रीक्वेंसी स्पीड कम या ज़्यादा कर सकते हैं, सेम मत रखो, तो दोनों वेवफॉर्म सेम ही जनरेट होंगे, दोनों एक साथ 0 रहेंगे, दोनों एक साथ 1 रहेंगे. सो टू अवॉइड दैट मैं इसको स्लोअर कर देता हूँ एंड असाइन करता हूँ. Right, so clock 1 and clock 2. Now same clock 1 and clock 2 should be given to PMOSes also. तो for that reason there is one option, either मैं clock 1 सेम यहाँ पे असाइन करूँ या फिर ये पूरा रेड कलर का ऐसा लाइन ड्रॉ कर लूँ. सो दिस इज़ ओके फॉर दिस ट्रांजिस्टर. और ये वाले के लिए मुझे यहाँ से ऐसे गोल घुमा के लेके आना पड़ेगा. सो दिस इज़ ऑल्सो ऑप्शन अवेलेबल. अदरवाइज what I can do, इसका जितना frequency रखा था same frequency I will connect to this location. So instead of clock 3 I will take it as clock 1 and I have to check the frequency, इसका कितना था same I have to give it here. So double click, check करो क्या है 0.225 0.025. So same should be given to the other clock also. Close, double click. So this should be same, then only input A and input A will be same to both the transistors. So give the value 0.25 225 and 0.025 was as it is, right? Again we will verify whether our values are correct. 0.025 and 0.225. So same values are assigned now to both the clock 1. Similarly for clock 2, 0.975 and 0.025. So again I will assign a new clock to this terminal, give a name clock 2 only. 0.975 0.025, same it is showing assign. So I have applied all the inputs, output is also connected, VDD VSS is also connected, and diagram is okay. So I will click on all so that entire diagram will be centralized, and I will check for the errors if there are any errors. So if I click on this, it is showing DRC error that this width is less than 3 lambda, means I have to increase the width. So I will try to increase this width. So in such a way you have to remove the errors. Again I will check for the DRC if there are any more expected corrections required. So again it is asking this width is less than 3 lambda, it should be wider. I will try to increase its width. Then again check the DRC. Now they are saying this space between the metal is less than 4 lambda, it should be more, this gap should be more, otherwise it will act as capacitor. So option is go to all. I have to move this lower part of the circuit so that there will be a difference. ये जो गैप दिख रहा है ना ब्लैक, ये बहुत छोटा गैप हो गया, ये मुझे बड़ा करना है, इसलिए आई एम ट्राइंग टू कॉपी ऑल द लोअर पार्ट ऑफ द मटेरियल एंड आई विल ट्राई टू स्ट्रेच इट far from the previous circuit and then try to stretch it out so that connection will be there. This also I will keep it somewhat above. Now in this case what happens, output goes out of the metal, so I have to delete it and again I have to place the output. Delete, place an output here. Or gun was selected, mistake. Control U, select a pencil and then select I. Give the name output assign. So after doing this, select all, again go for DRC. और कुछ error है क्या? No. So if it is not showing anything, means there is no error. There are no further errors to solve. Just click on play. It will show you the outputs. So if you can see clock 1 now, as we have copy pasted it multiple times, it has shown us 4 clock pulses, but in our case there should be only 2 input. So we need to again check that there are differences between these two waveforms. These two are equal, matlab clock 2 is showing no mistake, clock 1 should be the same of this one. So we have to change this. We have not changed one of the parameter of this clock 1, and as it is a NAND gate, what it should be, both are 1, then only output should be 0. So this 0 interval is applicable for this one and this, but what about this? So we have to again check the clock signal. So clock 1 values are not matching. 1.2, 0.0, 0.225, 0.025, 225 and 0.025. Same we have to check for this clock 1. See, here there is a change. High time is different. It should be the same, 0.225. Now we'll see. Now it is showing. So both the clocks are same. This is input A, this is input B. So for both the input A and B, we have to check when both are 1. that time output should be 0. So this is 1 as well as this is 1. So that time output is 0. Rest all the time output remaining 1. This is also the interval where both the waveform remains at logic 1. So this is the output of your NAND gate. So you have to verify this logic gates and you have to show this rise time and fall time. So rise time is 8 picosecond, fall time is 5 picosecond. You can change the interval if you want to see in detail. You can increase, you can decrease the width, and you can see the multiple waveforms. So this output is expected. After that, last part is you have to add a capacitor also, because you have to see the capacitive effect on the output. So go here, palette, select capacitor and drop a capacitor here. You can select the value of capacitor also, how much picofarad value you want. So you can assign whatever value you want. The more capacitive value you will add, rise time and fall time will increase in that proportion. Click on OK. Capacitor is added. So previously rise time and fall time was 8 picosecond and 5 picosecond. Now after adding a capacitor, see, value has been changed to 26 picosecond and 20 picosecond. So this effect has happened because of adding a capacitor. My output has become more slower. So that's why capacitive load effect has to be monitored.